Welcome back to Concepts in Arithmetic. We are at the point in the course where we need to discuss the algorithms for the operations of addition, subtraction, multiplication, and division that your students will encounter in the K3 curriculum. So you might not quite know what an algorithm is. You've probably heard the word before, but just so we're all on the same page, an algorithm is a step-by-step list of instructions that solves an entire class of problems. Okay, now we have algorithms working all the time in the background because computers are great at executing algorithms. Computers are built to execute lists of instructions. And the reasons that we need to teach algorithms are, one, they always work. Okay, you have a method that will solve a problem for you. After a while, algorithms become automatic. And this actually allows students to think a bit more conceptually because they know that they have a process they can follow that will get them the answer. So that frees up some working memory to deal with other parts of problems. And learning the algorithms in the primary grades actually completes the topic of arithmetic entirely and gives us a level playing field. So once you hit the algorithms, all your students should be able to do all the operations. Mental math involves a little bit of creativity, and there's several different ways you could tackle a problem with mental math, but in algorithms, this step-by-step process. Okay. So as far as prerequisites go, students will need to be able to count into the hundreds. They will need their one-digit addition facts down pat. They'll need their two-digit mental math. Okay. So the first kind of problem that students will tackle when they're dealing with this addition algorithm is adding units of a single denomination. So, for example, you might ask a student, what is 30 more than 147, question mark. Okay, so if we ask him that question, we can write it here in a chip model. So we'd have a hundreds tray, we'd have a tens tray, we'd have a ones tray. Okay, we would load in 100, 4 tens, and 1, 2, 3, 4, 5, 6, 7 ones. Okay, and the point is that the student needs to understand that we add 3 chips here to this tray, and that's what we need to do. Okay, you're adding a multiple of 10, you focus on the tens place. And of course, when you're dealing with addition problems, you will need to know rebundling. Okay, so students have to have a sufficient grasp of the place value process before they can start to tackle the addition algorithm. In other words, they have to know that if you have 10 chips here, you need to be able to take those out and replace them with a single chip over here in the hundreds tray. Now, as you get students working on problems, you would start by introducing addition without rebundling. So, for example, if we were to do 231 plus 724, very quickly, we'll do the chip model. 200s, 30, 10s, and then 1. So we load in 231, and then we load in this next number. So we load in 4 more in the ones place, we load in 2 more in the tens, and 1, 2, 3, 4, 5, 6, 7 more. And then we can count these up. Okay, so we have 5 chips in the ones tray. We have 5 chips in the tens tray, and we have 9 chips in the hundreds tray over here. Now the idea is, as we're teaching this to our students in the K-3 curriculum, we want to move pretty quickly from these pictures to this over here. And when you're doing your homework, I would also mention that you should avoid doing the chip model unless you are explicitly asked to do the chip model. So when you're working as a pre-service teacher, think this. Have this in the back of your mind, be able to do it if needed, but don't default to the chip model. Okay, now stage 3 here, where we've gotten problems that are a bit harder. This will be addition with rebundling. Okay, so for example, if we were to do 27 plus 46, we start the exact same way. We load in 2 tens and 1, 2, 3, 4, 5, 6, 7 ones, and then we load in 1, 2, 3, 4 tens, 1, 2, 3, 4, 5, 6 ones. Okay, so now that we've loaded in both of our add-ends into each tray, we look at this ones tray and we see, all right, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We got 13 things in here. We're going to take 10 of them and we're going to remove those 10 and get a new tens chip. 1, 2, 3, 4, 5, 6, 7. Okay, so let me go ahead and take, I don't know, that's 5 right there. Let me take those out and give me a new chip. That's the new rebundled chip. Okay, so we're left with 3. We're bringing a new tens chip over, so we record that up here. And now we can see we have a total of 7 chips in the tens tray. Okay, so the chip model should illustrate what is going on here with the standard algorithm, the standard pencil and paper algorithm. In other words, we know, because we're so familiar with it, you do 7 plus 6, that's 13, you carry the 1. Okay, the chip model is illustrating that. We had 13 here in the ones tray. So we take 10 of those, we remove them from the ones tray, getting a new chip in the tens tray. Okay, so that's the basics of the addition algorithm using the chip model.